File transfers. The term post-exploitation refers to the actions performed by an attacker once they've gained some level of control of a target. These actions include elevating privileges, expanding control into additional machines, installing backdoors, cleaning up evidence of the attack, uploading files and tools to the target, etc. Considerations and preparations. The methods we discuss in this module could endanger the success of our engagement and should be used with caution and only under specific conditions. To begin, we'll present some warnings, prepare our Kali machine for the exercises, and demonstrate and overcome some file transfer limitations inherent in standard shells. Dangers of transferring attack tools. In some cases, we may need to transfer attack tools and utilities to our target. However, transferring these tools can be dangerous for several reasons. First, our post-exploitation attack tools could be abused by malicious parties, which puts the client's resources at risk. Second, antivirus software, which scans endpoint file systems in search of predefined file signatures, becomes a huge frustration for us during this phase. As a general rule of thumb, we should always try to use native tools on the compromised system. Alternatively, we can upload additional tools when native ones are insufficient, when we've determined that the risk of detection is minimized, or when our need outweighs the risk of detection. Installing pure FTPD. In order to accommodate the exercises in this module, let's quickly install the pure FTPD server on our Kali attack machine. Before any clients can connect to our FTP server, we need to create a new user for pure FTPD. This bash script will automate the user creation for us. It creates the relevant group and user, configures folder permissions, and starts the FTP server. We'll make the script executable, then run it, and we'll enter lab as the password for the OffSec user when prompted. Now that our FTP server is installed and configured, we can continue. The non-interactive shell. Most Netcat-like tools provide a non-interactive shell. This means programs that require user input, like file transfer programs, SU, and sudo, tend to work poorly in these shells if they work at all. Non-interactive shells also lack useful features like tab completion and job control. An example will help illustrate this problem. Let's first connect to our Debian lab client via SSH. You're already familiar with the ls command, which is non-interactive because it can complete without user interaction. By contrast, consider a typical FTP login session from our Debian lab client to our Kali system. In this session, we enter a username and password, and the process exits only after we enter the bye command. This is an interactive program. It requires user intervention to complete. Although the problem may be obvious at this point, let's attempt an FTP session through a non-interactive shell, in this case, Netcat. To begin, let's assume we've compromised a Debian client and have obtained access to a Netcat bind shell. We'll launch Netcat on our Debian client listening on port 4444 to simulate this. From our Kali system, we'll connect to the listening shell. Now, let's attempt the FTP login again. Behind the scenes, we're interacting with the FTP server, but we're not receiving any feedback in our shell. This is because the standard output from the FTP session is not redirected correctly in a basic bind or reverse shell. This results in the loss of control of our shell, and we're forced to exit it completely with Control-C. This could present a huge problem for us during an assessment. Upgrading a non-interactive shell. Now that we understand some of the limitations of non-interactive shells, let's examine how we can upgrade our shell to be far more useful. The Python interpreter, frequently installed on Linux systems, comes with a standard module named pty, which allows for the creation of pseudo-terminals. We can use this module to spawn a separate process and upgrade to a fully interactive shell. First, we'll reconnect to our listening netcat shell, and invoke our pty shell. Immediately after running our Python command, we're greeted with a familiar bash prompt. Let's try connecting to our local FTP server again, this time through the pty shell, and see how it behaves. This time, our interactive connection to the FTP server was successful, and when we quit, we're returned to our upgraded bash prompt. This technique effectively provides an interactive shell through a traditionally non-interactive channel. Transferring files with Windows hosts. In Unix-like environments, we'll often find tools such as netcat, curl, or wget pre-installed with the operating system, which make downloading files from a remote machine relatively simple. However, on Windows machines, the process is usually not as straightforward. In this section, we'll explore file transfer options on Windows-based machines. Non-interactive FTP download. Windows operating systems ship with a default FTP client that can be used for file transfers. To demonstrate this, let's assume we've compromised a Windows target and have access to a bind shell. We'll run a netcat listener on port 4444 on our Windows machine to simulate this. Now we'll close our desktop and continue through the bind shell. As we've seen, the FTP client is an interactive program that requires input to complete, so we need a creative solution in order to use FTP for file transfers. The FTP help output hints at a feature that could help us. The -s option accepts a text-based command list that effectively makes the client non-interactive. On our attacking machine, we'll set up an FTP server and initiate a download request for the netcat binary from the compromised Windows host. First, we'll place a copy of nc.exe in our FTP home directory. We've already installed and configured pure FTPD on our Kali machine, but we'll restart it to make sure the service is available. Next, we'll build a text file of FTP commands we want to execute using the echo command. The command file begins with the open command, which initiates an FTP connection to the specified IP address. Next, the script will authenticate as offsec with the user command and supply the password lab. At this point, we should have a successfully authenticated FTP connection, and we can script the commands necessary to transfer our file. We'll request a binary file transfer with bin and issue the GET request for nc.exe. Finally, we'll close the connection with the BY command. We're now ready to initiate the FTP session using the command list that will effectively make the interactive session non-interactive. To do this, we'll issue the following FTP command. We use -v to suppress any returned output and -n to suppress automatic login. Then we'll use -s to indicate the name of our command file. When the FTP command runs, our download is executed, and a working copy of nc.exe should be transferred to our client directory. Windows downloads using scripting languages. We can leverage scripting engines such as VBScript and PowerShell to download files on our victim machine. For example, the following set of non-interactive echo commands, when pasted into a remote shell, will write out a wget.vbs script that acts as a simple HTTP downloader. Let's select all of this and copy it to our clipboard. We'll also copy the Windows version of wget to our web root so we have something to download. Now we'll paste our echo commands into the Windows bind shell to create wget.vbs. Now we can run our wget.vbs file with cscript to download files from our Kali machine. The script requires a source URI and the local file name for the download. Great! Our file was downloaded correctly. For more recent versions of Windows, we can use PowerShell as an even simpler download alternative. This example shows an implementation of a downloader script using the System.net Web Client PowerShell class. Let's copy this to the clipboard and paste it into our bind shell terminal. Now we can use PowerShell to run the script and download our file. However, to ensure both correct and stealthy execution, we specify a number of options in the execution of the script. First, we must allow execution of PowerShell scripts with the execution policy keyword. Next, we'll use no logo and non-interactive to hide the PowerShell logo banner and suppress the interactive PowerShell prompt, respectively. The no profile keyword will prevent PowerShell from loading the default profile, which is not needed, and finally we specify the script with file. Rather than creating a script, we can execute all of the commands as a one-liner. If we want to download and execute a PowerShell script without saving it to disk, we can once again use the System.net Web Client class. This is done by combining the download string method with the invoke expression commandlet. To demonstrate this, we'll use a simple PowerShell script on our Kali machine. Next, we'll run the script on our compromised Windows machine. The content of the PowerShell script was downloaded from our Kali machine and successfully executed without saving it to the target's hard disk. Windows downloads with exe to hex and PowerShell. As we've seen in a previous example, PowerShell is incredibly powerful and is installed by default in all modern versions of Windows. In the following example, we'll transfer a binary file using PowerShell by taking a somewhat circuitous, although very interesting route. Starting on our Kali machine, we'll compress our binary, convert it to hex, and create a Windows script. On the Windows machine, we'll paste the script into our shell and run it. It will redirect the hex data into PowerShell.exe, which will assemble it back into a binary. This will be done through a series of non-interactive commands. As an example, let's transfer netcat from our Kali Linux machine to our Windows client over a remote shell. We'll start by locating and inspecting the nc.exe file on Kali Linux. Although the binary is quite small, we'll reduce the file size to show how it's done. We'll use UPX, which is an executable packer, also known as a PE compression tool. As we can see, UPX has decreased the file size of nc.exe by 50%. Despite the smaller size, the Windows PE file is still functional and can be run as normal. Now that our file is optimized and ready for transfer, we can convert nc.exe to a Windows script to run on the Windows machine, which will convert the file to hex and instruct PowerShell to assemble it back into binary. We'll use the excellent exe to hex tool for this conversion process. Notice how the commands in this script are non-interactive, mostly consisting of echo commands. Towards the end of the script are commands that will rebuild the nc.exe executable on the target machine. We can copy the entire script to the clipboard by piping it into the xclip utility. Now let's paste it into our bind shell. After pasting the script into our shell, it does in fact create a perfectly working copy of our original nc.exe. Windows uploads using Windows scripting languages. In certain scenarios, we may need to exfiltrate data from a target network using a Windows client. Fortunately, if outbound HTTP traffic is allowed, we can use the System Net Web Client PowerShell class to upload data to our Kali machine through an HTTP POST request. To do this, we can use this PHP code, which will process an incoming file upload request and save the transferred data to the var www uploads directory. We'll create the uploads folder and modify the folder permissions, granting the www data user ownership and write permissions. Note that this would allow anyone interacting with upload.php to upload files to our Kali virtual machine. Generally, we would want to exfiltrate some interesting documents we've found, but for the purposes of this demonstration, we'll simply exfiltrate the evil.exe binary to our Kali attack machine. With Apache and the PHP script ready to receive our file, we invoke the upload file method from the System Net Web Client class to upload the document we want to exfiltrate. After executing the PowerShell command, we can verify that the file was successfully transferred. Excellent. We were able to upload data from Windows to our Kali system without installing any additional software. Uploading files with TFTP. During a penetration test, we can use TFTP to transfer files from older Windows operating systems up to Windows XP and 2003. This is a terrific tool for non-interactive file transfer, but it's not installed by default on systems running Windows 7, Windows 2008, and newer. For these reasons, TFTP is not an ideal file transfer protocol for most situations, but under the right circumstances, it has its advantages. Before we learn how to transfer files with TFTP, we first need to install and configure a TFTP server in Kali. We also need to create a directory to serve files and configure its permissions. Now, we'll run aftpd, the TFTP server, as a daemon on UDP port 69 and direct it to serve files from the /tftp directory. As we did before, we'll reuse one of the binaries we previously uploaded to the victim machine to simulate data exfiltration. We'll run the TFTP client with -i to specify a binary image transfer, followed by the IP address of our Kali system. Then, we'll use the put command to request an upload and pass the file name of the file to transfer. Great. We now have yet another technique to transfer files to a compromised system. Wrapping up. In this module, we focused on post-exploitation file transfers. We learned about traditional file transfer methods, such as FTP and TFTP, and learned how to upgrade non-interactive shells. We also focused specifically on Windows-specific file transfer methods using various scripting languages, as well as how the exe to hex utility can be used to transfer files. We can use these methods in various ways during an assessment to help transfer tools or data into or out of a target network.